And boom, we should be live, I think. All right, welcome to the number one. This time, we're gonna do something that somebody asks me actually. I got an email from Aditya asking me about how do you show NFT on your app or website. And I figured, well, that's such a good question, and I failed to address that before, so I'm gonna do just that. So it's gonna be fun stream. We're gonna a little bit build on top of what we've done last time, which was, we've built these Beaver NFTs, and now we're gonna show them in the React app real quick. Cool. So to understand what I mean by that, this is a project I'm working on, Motaverse at the moment. But here we have NFTs. These are motorbikes, and you want to show them on the app. So this is a React app, and we're showing like the actual NFTs, right, for the logged in user. Yeah. So we're gonna do something very similar, but for our Beaver NFT, and it's gonna be a little bit simpler. So if you remember last time, let's go back here. Let me make it bigger. Yes. If you remember last time we did this, I guess let's do truffle console. So next I'm gonna fetch the address of the contract we deployed last time to see it on the marketplace on the OpenSea, and then we're gonna try to do something similar as well. So we used the Rinkaby test network for it, so let's do that. So right now I'm just using Truffle to connect locally, or like to connect to the Rinkaby network, and the only reason I'm doing this is so I can fetch NFT contract that we've done before, which was Beaver NFT deployed. By the way, this is a way you can do to kind of figure out what was the last address of this contract that you deployed with Truffle, because it has this migration smart contract linked to it. It can look up the addresses, so you can do NFT address here, and now we have the address of the smart contract that we've deployed. It might be the one I've deployed today. Let's open this guy. And let's just go to, yeah. Oh no, sorry, this is a different network. Let's go to Rinkaby and open that. And then this is the address I copied. So this is the address of the smart contract, presumably. And we can see this is the one I've done today. So there are some mints and transfers. And anyone's not on the OpenSea yet, I think. But it's okay. Let's look at that. So last time we would go here, live on testnet, put in the address, and we would get our NFT. Right? So we can see the two beavers are happy here. But sometimes in some use cases you would like to build something like this on your own website or in your own app. So maybe they have some utility that you want in your app to be used, like in the case I showed you before in the Motaverse, which, yeah, it's a different network again, so I'm not gonna be doing that anymore, but you would just like race the bikes, and for that we need the bike on our website. Another use case that somebody talked to me about is that they have a restaurant and they would like to sell NFTs at their restaurant for the patrons in the restaurant, so that people get some benefits of it. So they could get free dessert or every third beer for free or something. But you want to show these NFTs to people on your website as well, not only on some marketplace somewhere. Because your end goal is to attract new people to get this NFT, right? And people might not be aware where the current marketplace, where you have listed your NFT, but they know where your website is. So you could show it there and then link them to the marketplace if you don't want to build marketplace yourself. which is also an option. Cool. So if you start thinking about how to do this, the first problem you run into, or not a really problem, it's just by design, but is that this ERC721, which we were using, like if we look at the interface of it, these are all the methods that you can do towards that smart contracts to get any sort of information. So let me make this a little bit cleaner. What you can see, you can check how many tokens one person have or one address owns. You can check who's the owner of individual token ID. And then you can do some transfer method and approvals, which are not important for us at the moment. And that's it. So one thing that we are missing here is kind of list all the tokens one address owns. And that's a problem because you don't have that option. You can't list all the options, all the tokens you are supposed to look at. So there are two solutions, or like many solutions to how you solve this problem. But one way, how like OpenSea is doing it, right? They're listing it, and you can look at the NFT, and you can even see the owner, I guess. It's owned by you here, okay. And you can see all the NFTs they own. But how they do it is that if you look back at Etherscan, this is the smart contract that we looked at, this is the address of the smart contract. And you can kind of listen or like replay all the history on that blockchain, like go through all the blocks that happened in the past and all the transactions and decode them, kind of figure out who end up owning this NFT. Like here, the first mint transactions, they, like if we look at one of them, here it says token transfer from 00 to some address, and it's a token with ID 0, right? So now we need to remember this address owns token with ID 0, right? So now we're going to look at the other transaction, and then token ID goes to this address. So now we remember token 1 is also owned by the same address in this case. And then we look at this transaction, and then we see that token 0 is no longer owned by this person, but goes to some other wallet, right? And you need to build this so-called index of the blockchain. So you would need to build this kind of database of who owns what, or like whatever information you want to store. And obviously, like both Etherscan actually and OpenSea are doing that because that's their main business, right? But in your case, you want to build your own website. You might not want to do that. You might not want to, build a database and store it on some sort of, have some sort of backend logic that goes through the transactions and catch ups and keeps track of who owns what. And there's a way to avoid this, which we're gonna do today. So to avoid this, we would change our smart contract a little bit so that we will start tracking who owns which tokens, basically, like the other mapping as well. Right now we tracked who's the owner of certain token, but we also want to track per owner which tokens they own, which we didn't before. This is a little bit confusing, sorry about that, but yeah, now hopefully it's gonna get clearer when we get into it. And again, here we don't need to like reinvent a wheel. Last time we just used ERC721 implementation by OpenZeppelin, and basically we just did very small code here to make it work for us. And we can do basically the same thing for our purpose right now. So if we look at what OpenSea has done here, so they have this ERC721 implementation, which is what we've been using. It has a lot of stuff. You can look into how it works. And then there are these extensions. So what are these extensions? These extensions are, if you want something more than the standard ERC721 gives you by default, you would go and implement one of these extensions. and they are really good. We were actually using already one extension, although it wasn't explicitly mentioned, and it was the metadata one. Because ERC721 doesn't have metadata by default, but there is one extension, this metadata, that, you know, if we look at that, it provides a token URI method, which whoever wants to can call this method and get, you know, the JSON metadata that we're gonna use later as well. But then the extension we're interested in is this enumerable extension. This gives you one total supply, which we used to implement our own way, but now we're going to use this standard implementation instead. But second, it gives you this way to iterate over items that person owns. So these methods, they look a little bit cryptic because, you know, you would expect something like get me a list of, you know, token IDs. But lists and iterations are kind of very difficult, or not difficult, but they made it so that it's unpredictable how much you can spend on a gas fees if you would use them, because it then depends on the size of the array, right, that you're iterating over. And then you don't really want to have this like uncertainty in your smart contracts. So the idea is to push it outside, to have it this iteration in your application logic. And we're going to do the same thing. So we're going to iterate over IDs, and then for each ID, we're going to go in here and use actually this method to fetch the IDs. Well, I bet this is super confusing right now, which I'm sorry about. It's going to get cleaner when we get into the implementation part, hopefully. Cool, so this is the interface. There's this implementation as well, like you can look into it, what it does. Again, it's probably a good idea if you're going to be using it. And yes, please look at that. So hello, I'm getting some conversation in the chat. Yes, I'm kind of blockchain developer, not like that's not my main thing that I'm doing, but my day is going great, thank you. And I think I renamed the channel from Sopho to Beaver Codes recently, so maybe that's why you don't remember using this. So that the name kind of matches the YouTube channel. It was kind of bad naming it from the beginning. So right now, let's use the enumerable thing here. So I've already forgot the path to it, of course, so I'm gonna just copy it and then replace this. And we don't need that. So now instead of importing the ERC721 directly, we're gonna be importing this one. And we're gonna be, you know, what's the word? Inheriting from this enumerable instead of the ERC721 exactly. But if you look at the implementation of it, it in turn inherits from the base ERC721. So we have all the functionality we had before plus some extra. Like one extra thing that we got is this total supply tracking. So we no longer need to track it ourselves because the enumerable does that for us. So we can just drop this nonsense. And this turns into like a function call. I'm not going to spend too much on that because this is more about the React part. So I'm not going to like torture you with the Solidity stuff. Okay, so this is hopefully all the changes we needed for this. Let's open our terminal. And then we can do compile here, just to make sure everything still works. This looks good. And then the second thing we can do is deploy. And then do with reset, because we've already deployed this contract and we haven't provided a new migration, which again, I'm not going to bother you with, but you know, if you would be alive, you would add a new migration here and do that instead. But because this is still test and this is still preparation to the main task, I'm just gonna skim over that. But we're gonna get a new smart contract deployed real soon, and we're gonna play with that. It's gonna be super cool, I promise. Yeah, it's still doing its stuff. Yeah, the Solidity language looks a little bit different to me as well from the beginning, but you get used to it. Like the type annotation here, right? That's not something you used to, especially if you're going from like front end stuff, which loads of people are. Uh, you either don't use types if you just use plain JavaScript, or in TypeScript you would put types at the end with the colon. We're gonna see in the second part. Yeah. I have a question if it's mostly used to create blockchains, the Solidity language, that is. The answer is no. The blockchains themselves, like Ethereum blockchain or like Avalanche blockchains, they would be written in some other language, some probably very performant language, something like C or something like that. That would be my guess. But then you have in these blockchains, you have this so-called Ethereum virtual machines or EVMs that runs other type of bytecode or like code. And one way you can produce this bytecode is writing Solidity, which is this code right here. And then you compile that to create this bytecode. Then this EVMs inside the blockchain runs. So the blockchains themselves are programmed in different language, but the smart contracts that runs inside the blockchain would be written in the Solidity. Cool. So this has finished. So now what we can do is hopefully fetch the newest version of the NFT. So now we should have this new method, total supply, that we didn't have before. And looks like we do. What we can do is this result obviously looks horrible because it's a big number which is not shown nicely. So if you want to see it nicely, you would like put it in some variable, like so. Boom. And then do toString on it. By the way, the thing I'm writing down here in the console, this is Truffle's console. And this is a web-free library that we're going to use later. But that library is JavaScript library. So the code you're doing here is JavaScript. So that's, yeah, what I wanted to mention. And then JavaScript doesn't have a support, like native support for these big numbers that we need, because they're just too big for the number, type that we have in JavaScript. So instead of what you do is you use some other class implementation of these big numbers, and they store them differently. They store them differently. And then if you want to have, you can do toString, which loses a precision. But in our case, it doesn't matter, right? Because we're just looking like small numbers, so it's fine. We're looking how many there are tokens. But if you would go into the high numbers, you get the wrong results here. Well, not toString, but toNumber. Cool. So that's working now. What we can do is we can mint few of those tokens. So now because we just created this fresh new contract, we're just minting a few NFTs, so there is something we can actually show on the website. So there is more like, nice. This looks pretty nice. Let's do one more. And in the meantime, second thing I'm gonna do is in this project, which is on GitHub, by the way, I'm gonna send links to it, of course. We're gonna create a new folder that's gonna contain our front end. So what you would do, you would just do create React tab. Let's just use npm, it's because I'm old school. And then we can say template TypeScript. And that's because, I'm just too lazy to not use TypeScript. Yes, and then we do from that. This should be it. Let's do this. So this create React app, if you haven't used that before, that's kind of bootstrap tool that lets you quickly start a one-page application where most of the thing that you see is built by, or like 99% of the code that you see is built by JavaScript. So it's not built by HTML, which you would do traditionally back in the past, or you still do, like on WordPress, right? For instance, you would still do HTML there for many cases. And then you would build a HTML structure inside your JavaScript and then print that out. One of the libraries, the most popular one used nowadays, is React. And these libraries, they give you they do the same thing as every library does. They give you some sort of level of abstraction so you can write less code to get the same amount of work done. And yeah, so we're gonna use React to just do very minimum. Cool. Nice. I think I messed up my chat thingy here. I don't know if it still works. But, as you can see, I'm a very experienced streamer and I understand how chat works, so that's why it just told me it's paused. But maybe it's not paused. I don't know. Cool. Finally, it finished doing stuff. So now we can go to this front end place and do what people told us to do. Yes, so now it's compiling. This is good. This all looks really good. So if we open localhost 3000, which is where it opened it, let's do like this fancy thing. Can I even do this? Yes. Is that? So what happened here is that we got this new folder here called frontend, and it created a lot of files for us, including this. We basically can get rid of this JSON CSS, which is gonna break the site. We don't need the test file. We still have that. That's fine. And the rest is fine. Cool. And then React is, I would say, simple because yeah, I kind of like it. So let's, you change code here, do something, and if you save, it's gonna happen on your screen on the right there. So one more thing that I'm gonna do is I'm gonna fetch a library called Bootstrap. I think like that, Bootstrap. Bootstrap is CSS library. It's kind of makes your life easier if you're like styling stuff and you want to do it quickly. So we can do Bootstrap. What? Why are you? Yes, this CSS, and then there is Bootstrap.css. Like you would go through Bootstrap installation page to figure out why I typed these things. But this is not the main focus, so that's why I'm just like skimming through it a little bit. But if there are questions, I'm happy to go into it a little bit more deeper. So I used one of the classes that we get from Bootstrap, which is container. It kind of makes stuff more nicer, so that they're not spread around the whole page. So you can do like h1, our cool Beaver NFT viewer. Oops. Cool. That kind of works. So then let's get rid of that. We don't need that. Next step we we need some address to fetch data about. Like we want to look at some address and show what they contain, what kind of NFTs they have, what the Beaver NFTs they have. Normally what you would do, you would build some sort of authentication, or normally, like if it's more advanced app, you would use some sort of application where people sign in using your MetaMask. and then you get the account from the currently signed in user. For simplicity, right now we're just gonna create like input field where you put in the address that you're interested in, and then we're gonna show NFTs in that address. But you could do whatever, of course. Let's just make it a little bit more, give it a little bit more breathing room here. And then we can do label, boom, and then say address of the user that has all the NFTs. Looks pretty good. And then next up, we're gonna need an input item. It's gonna be text. And that's it for now. Again, let's put it some class name. Which one? I think it's form control. To make it nicer, yes. So you get this kind of nice effect. This comes from Bootstrap. So you can already type. And then next step is we want to capture whatever people put in here and use that in our JavaScript code to, fetch the NFTs. So next up, we're gonna need a state. Let's do that. So let's get an address. Set address and use state, and let's end it with nothing. And then here in the input, the value is gonna start with the address, and then on change is called on input on every keystroke. So we need to keep updating what the address actually holds. Like you could use some sort of library to do this for you. Like I kind of like the, what's the name of it? React form hooks. Is that the name? React hook form, the other way around. Yeah, I think this is on. This is my preferred way of doing this, like in the bigger app. But if we have just one input, it's not worth it to fetch this thing. And it also loads forever for some reason. Yeah, so you would use this if you want to be fancy. But we don't want to be fancy. Cool. And then next step is that we want to kind of make sure that what people type in here is actually, valid address. If it's not a valid address, then all our logic's gonna, go bye-bye. It's not gonna work. And so what we need is a way to interact with blockchain, finally. And to that we need another library. This one is called Web3. I already mentioned it when we were doing the truffle stuff right here. Right here, what you're doing, this is using Web3 library. And the truffle has already installed it for itself, and you can use it in this CLI tool. But we also need it in our, web app. So let's install it. Let's install it. This library has sort of like longer list of dependencies, so it's gonna take a little bit of time to finalize its installment. But in the meantime, I can maybe mention how this actually works. So Web3 is, piece of JavaScript code that you put on your app, and it knows how to interact with blockchain. So only thing it needs is like an address of a node within the blockchain. So as you might be aware, blockchain is just like a big network of nodes. Some of them are miners, some of them are like validators if you're proof of stake. But there are other nodes as well that are just like reading the blockchain and can provide you a way to submit new transactions or like read what the state of the blockchain is. So in Web3, you would have this library that you point to one of the nodes, and it knows how to communicate with the node. So this is what we're gonna do, hopefully. This looks good. No issues found. So let's import web3. Wait, no, web3 from web3. Cool. This looks pretty good. Weird. So this blew up for me when I was, maybe it's gonna still blow up. This blew up to me before I was trying it, and that's because Create React App had a release last week, which changed Webpack, which changed some other stuff, and in the end it didn't work for if you did the Web3 import. So I had to roll back because of the dependencies of Web3. But let's see. Maybe it's not packed yet because we're not using it. If it's gonna happen again, I'm just gonna tell you how to fix that. Cool. So a thing we can do with Web3 is like kind of check if the address is valid. Like it has a lot of things, but among them is utils, and then is address is the call that we're interested in, and then we pass in the address and it gives us a result if it's valid or not, right? So we can just console log it real quick. Okay, is it now that it's gonna fail? This could be very anticlimactic. Oops, yeah. So this is failing because of Webpack. You can read about this here. It's very sad. Hopefully what we can do is downgrade this one, React scripts, which is the one that got upgraded, like this 5 is quite new. I think 403 is the previous one, which is still fine. So then we can do, we changed it in package JSON. This is what I've just done. And then if I run npm install, it's gonna check package JSON and make sure our dependencies match this. And because we didn't put, you know, the upper sign here, it's gonna find the exact match, not try to, oh yeah, sorry, need to be in front end to do that. Not find anything that is this or higher. We said we want exactly 403. So it's gonna hopefully replace the faulty one. It's not their fault, right? It's of the internet's fault. With the older version that still works for our purpose. So let them do that part. It's gonna probably crash this, or we should crash this just to make sure, because we're basically changing the runtime that was doing this thing under its nose. So I don't know if it can handle that well. Yes. This is all fun. Well, I guess we can in the meantime continue our train of thoughts. So if it's valid, we want to do two things. One of them is like show some other section. So we can start doing this already. Oops. Where we would show the actual content of this world. So this looked like it installed all the dependencies, updated stuff. So we can try to do npm start again. Hopefully things goes well this time. Oh, this must have been loud. Sorry about that. Let's see. If this wouldn't work, then you know that would be a really boring video. Now it did compile successfully. So this still works. If we look at the console, we get this false here, like this valid is not valid. And if we copy some valid address, we get true. So that works. And then we get that. But what we would like to do is, you know, make some sort of visual feedback to the user that this is a wrong thing. So what we can do is here in the class names, do if it is valid, then you do nothing. But if it's not valid, then we're gonna add is invalid class, which is kind of this red thing, right? Yep. And then if we paste the real address, it's gonna go away. So this is all good. So if it's a valid address, we're gonna show have a header, I guess, and in there we're gonna say these are all the cool NFTs. This looks good. Let's give it a little bit of breathing room again, maybe even more. This looks good. Okay, and now we kind of need to load stuff, right? So let's just put something like this, loading. You would put a spinner here, right? Or something. So this is good for now. Next up, what we're gonna do is next up we wanna we don't need that anymore. So every time somebody changes this address, we wanna, you know, refetch all the data that we know about this address, like all the NFTs we know. So for that we can use effect, which is a way to trigger some sort of behavior based on if something changes or not. In our case, we want to change this if address changes. We're gonna run this code. So to, you know, demonstrate this, we can show address, you know, here. If you look at this, you know, damn it. Every time I type something, it changes. So now we don't really want to run this every time address changes, right? We really want to run it only if the address changed, but it's also a valid address. Otherwise, you know, who cares? It would fail anyway. So if we do that, the refresh, we don't get any console log, but then hopefully if we get our proper address again, we're gonna end up here again, right? So if it just goes back, you know, we're there again. So this is all good. So this is where we want it to be, I think. So what's next? Next, in use effect, you don't get to use asynchronous methods, but we kind of want to use asynchronous methods because all the Web3, you know, logic that we're gonna do next is async. You could do this kind of callback hell that JavaScript is famous for, like all the then and then, but let's not. So the way you can get around this is that you create a function right here. You're gonna call it, I don't know, fetch data. This is one of the worst name I've seen in the history of coding, but let's do that. And this one can be asynchronous, right? And then we're just gonna call it right here. Mistyping stuff. Boom. So now this code in here is asynchronous, and we can do whatever we want here. And it's gonna be triggered. So now it only triggers it, but doesn't like awaits it, but that's fine for us. We just need it to be triggered. And this is squiggly because we're using is valid, right? Yes. So that's it. Is valid to a dependency of this of this, you know, run as well. This looks pretty good. So next step, what we need is so-called Web3 instance. So as you can notice, I named it with capital V because this is actually a class, which if you know about object-oriented programming, you get these classes which if you're coming from blockchain stuff, that would be your smart contract. That's also a kind of class. And then if you deploy it, you get the specific instance of it. And we're gonna do the same thing. We're gonna take this class and then get an instance of it. So now to do this, it has several constructors. I just did control click, which gives you, because we're doing TypeScript, you can see what kind of parameters it wants. One of them is the provider here, which can be several things, but for our case, we can just do URL of the node that you want to connect to. That brings us back to the discussion about nodes in the blockchain. So we need a node to interact with, to kind of fetch data from. This is the important bit, right? We have our website, but it doesn't know what stuff is on the blockchain. It's not connected to blockchains itself, so it needs to go and reach to some other node that is connected and can give us this kind of information. Luckily, there are a bunch of services that can provide you this kind of nodes. One is Infura, which I'm not logged in here, which is very sad. So let me log in here. Need to fetch my password somewhere, which I can't find. Oh yeah, here we go. Nice. So, oh yeah, you don't do it here. You go here to settings, you create a project. Sorry about that. Like, you create the settings, it's kind of easy. And then you choose which network you want to use node in, and then you just copy the URL. And that's it. We lose this kind of cool setup. So now we're just going to put it in here. And that's our URL to our node. So that's all good. Let's go back here. Next thing, we need instance of our contract. To do that, we would do new, and then web3, and then ETH, and then contract. So now we're using contract. It has several parameters. First is the ABI of the contract, that we're gonna talk in a second what it is, and then the second is the address. So if we go back here, so we need this magical ABI, which we don't know what it is, and then second is the address of the contract, which we know what it is. If you look back here in the console that we are using before, we had this, I think contract was it contract? Did I call it NFT or something? Oh yeah, NFT. So we had an instance of a contract which was NFT, and then we can get the address of it. Here it is. So we're just gonna take this, and this is the address. That we know. So what's this ABI? ABI is an interface, basically. It's telling the library how to interact with this specific smart contract. Like what kind of methods I can call on this smart contract to get stuff done. And how you get it is whenever you run, compile here, truffle compile, it's going to do several things, but part of it is going to build all the artifacts that it needs in order to deploy that smart contract. One of these artifacts, they all end up in here, build folder. One of these smart artifacts is this file, which describes the whole smart contract. There's this bytecode, which is what ends up being deployed. But for us, the interesting part is that it also has this ABI section, which is, and this is all JSON, right? So it's perfectly human readable, not advisable, but yeah. So we just want to fetch this ABI. So let's do that. And then if we go here, let's just create a new file. Call this whatever, maybe beaver NFT ABI TS, and then export beaver NFT API. As you can see, I'm master typer. Cool, so this looks pretty good. like if you would inspect what this actually has, right, it describes the methods that we can call, like this total supply thing here, or like owner of. It's another method you can call, so it tells it what methods you can call. So now here we can just import our, how do I call it, Beaver NFT API. Now it's a little bit unhappy because it's TypeScript, so you can do as any here and everybody's fine. Cool. And that now comes the fun part. Now we're gonna start interacting with the blockchain. So up until now we were just like talking. But now what we're gonna do is we're gonna, like, let's try to call something, right? Just gonna call this balance because I'm just too lazy to rename it afterwards. But what we can do already is do contract methods, and then one of the methods is total supply that we know of, right? And then you can call on it, and then let's show what the balance is. And you can see that we got 3 here. So we already get to interact with the smart contract here. It told us that there are 3 items in this specific contract, which is because we minted 3 NFTs. Like if we mint one more, it kind of looks like I'm doing this on my computer, right? But and then you don't get to appreciate how cool this is. But which is very valid point. Now we have 4. But what actually happens is when I call this mint, it went all the way to the blockchain, to the Ringkaby shared network, got to these nodes that are all connected. They all kind of shared in between each other. Like, look, this is the new NFT. Yeah, cool, very much so. And then from our website, we would connect to some other node, or maybe the same, doesn't matter, and then fetch all the data we needed. Like in this case, how many tokens there are. And we got the right answer, which is kind of amazing. Cool. But we're not that interested in how many tokens are there in general, right? We want to know how many tokens this specific address has. Well, let's get rid of this. How many tokens this specific address has. So to do that, we can say, get me a balance of this address, right? And all these methods that I'm calling here, those are the actual smart contract address functions that I would do. So if we look back at our contract, which was Beaver NFT, like we can call token URI, you can call mint, you can call all the things that we get from the previous ones, which is, for instance, that one that we are calling. Cool. So this should give us some number. Yes. Let's test this as well. If this still works. Okay, cool. 4. That's probably true. Well, I guess what we can do is just send one to somebody else so that it's visible. Now we can do that later. Let's not worry about that. Cool. So the next point is we want to fetch all these tokens and get some information about them. Let's create some sort of interface because this is a TypeScript. Where we're gonna keep, track of stuff that are in specific items. Let's just do token RDD, which is gonna be string, I think, just for simplicity. This looks pretty good. And then we want to have like a state in which we keep track of what our Beaver NFTs are. So I'm saying here, use a state that is of type array of Beaver NFTs, and then I'm initializing it with empty array here, and then I'm gonna call it NFTs and set NFTs. Yes. One more thing we want to do, I think, is that we were showing this loading all the time. So let's only show it like before we've actually loaded stuff. So we can do useState and initialize it to true and call it loading and set loading. And then when we're done processing stuff, we're gonna hide it, right? We're gonna mark it so that it's not loading anymore. So right now, right down here, what we can do is that if it's loading, if it's loading, show this loading message. Otherwise, we're gonna show something else, some other text. Well, otherwise, let's just show diff, I guess. Oops. Oops. And then we can write some text here, like the address, whatever is the address, has you know, NFTs, length, NFTs, because we already know this information, right? I'm gonna fetch the address again. Oh yeah, so one more thing. When we're done with this, at the end, we're gonna set loading to false. Cool, so this kind of works. Let's just make it a little bit nicer. It still shows zeros, right? Because we haven't started filling this array yet, but we're gonna do that next. So kind of like this text muted by default, and then maybe the address can be this is gonna get ugly real quick. I don't know if this is gonna work. Let's see. I'm trying to make the address blue. Yes, it's blue. And let's do the same thing for the text, for the number here. Perfect. We need some spacing. No, you're not happy with this? Of course not. Nice, this looks good. So this address has 0 NFTs. Well, but it actually has some NFTs, so let's fix that first. So in here, let's say new NFTs equals array. And then what we can do is we can say this is Beaver NFT array. This looks pretty good, I think. And then do a for loop in which we're gonna go over the balances. Looks good. And then in the new NFTs, we're gonna push one item in it. So we don't know the token ID yet. What? Oh, it doesn't like. No, doesn't matter. We don't know the ID yet, right? Because we just know that the user has so many balances, like 5 maybe, but we don't know the IDs actually. It's not the index, that's for sure. But right now we are able to create as many items in this array as there are NFTs. So this is gonna help us, fix this 0 here to be the correct number. So if this works, we should be able to just set NFTs to this new NFTs. Oops. And then you can see it already shows 4, which is the correct number. But this is still kind of boring. Like we wanted to show the NFTs, and when I said that, you probably expected the, the images and stuff. So let's do that. Before we do that, And then he continued to not do that. Now let's show let's do like a row here, right? This looks pretty good. And then we gonna, for each NFT, we're gonna map that bad boy into another div. Oops. And then this one's gonna be call for, which just means like make them free in the row, which is a weird name for it, I realize now, but that's how life works. Which, you know, it created 4, doesn't look like that, but you know, if we put some text here, hopefully it's gonna be better. Nice. So now next up we wanna, you know, do like something like H5 probably, and do like the NFT token ID kind of thing, but they are all zeros because we haven't fetched the correct IDs yet. But that's what we're gonna do very much next. So okay, so now we know that the person has 4 NFTs in this case, right? Or the wallet actually can be bought or whatever. So now for each of these, we're gonna fetch the ID, if that makes sense. So for that, we're gonna use this new method that we added to our contract, which is called, I don't know what it's called. Let's look at that. Let's look at this. And let's look at the interface that we added. So we added these functions: total supply, token by index, and token of owner by index, which is what we want. So what does this do is we take an address, which is, you know, this address of ours, and then we say index. So give me a token ID of a first NFT that that person owns, and then show me the second and third and fourth. And because we use the balance, we know that there are 4 of them in total. We just need to find out the IDs of them. And this is exactly what this method is for. So if we go back here, call that, and then we say address, and then the index, and then we call it. And that's the way you do it. Cool, and then we're gonna replace with token ID. If, you know, in JavaScript, one of the things is the key is the same as the value. You just get to drop the value thing, and it kind of works still. And look at that, it already shows 0, 1, 2, and 3. And this is pretty amazing, I think, because we're already fetching some sort of data right now. But this is not good enough for us. No. Okay, let me get rid of that. So next up, we want to fetch the metadata about the image, about the NFT, which includes the image itself and all the parameters. So let's do that. So token URI, if you remember from the last time, this is a way to fetch URI, which is a URL that leads somewhere. And then it wants the token ID, which we now have. Oh yeah, sorry, where am I? Yeah, we need to do it per token. So token ID here, and then call it. And then I'm gonna console log it just real quick. So this is what we get. If you look in the console, like these addresses is what we get. If we click one of them, you get this JSON with all the information about the NFT. So we just now need to implement the when you click that part. So let's do that. Let's next up, what we're gonna do is just do like regular, you know, Web 2 HTTP request towards this new URL that we just got. So we can use fetch for that, and then you just put in the URI, and that's all good. And then you will get a response object which contains a bunch of stuff like headers and stuff, and you're only interested in the body. Metadata metadata. Metadata, I guess, is what I meant there. And you do JSON, and it gives you like a JSON object back, contains all the metadata. And let's fix the naming here as well. Metadata. Boom. And then let's console log that thing instead. Let's look at that. So now we're getting these objects here, right? And they have name, image, external URL, all the cool stuff that we wanted. So that looks pretty good. So let's take the image from here. That's the low-hanging fruit. Let's do that. So let's say our Beaver NFT now needs to also have image. This is pretty cool. So then, image here is gonna be metadata dot image. Looks straightforward enough. And then, this kind of works. But then let's here put like a like an image. And then for the source of it, we're gonna use whatever our NFT object have in image. And let's give it alt, like a beaver. This is amazing, I think. It kind of broke the whole application, but it's all good. So the reason it's broke is because the image just takes all the places it can get, and this is like higher quality a little bit than what we expected. But you can just make it, with 100%, and this will fit it in the containing thing. This is pretty cool, I think. One more thing that we can still do is, did I lose it? I don't know. No, I'm still console logging it, so let's look at that. So in this object, apart from the image, we also have these attributes. So quite often, if you're doing like a game or something, there are some attributes you want to show on the page. And in this case, we have hardworking and efficient, how much the individual beavers are hardworking and efficient. So let's show that. So then, oi, I closed it. Sorry about that. Localhost 3000, and then the address is this. Boom. So let's add one more row down here, which is going to be for the traits row. Boom. And let's add just 2 columns here. And first one's going to be, what was the hardworking one? And then the second one is the efficient one. Cool, and now we just need the values, right? So how do we parse that from here? So let's add one more thing in here, which we're gonna call traits. And this is gonna be a record of string to value. Sorry, number. What am I? Crazy? What? Now this is red squiggly lines because obviously we haven't put it there, so let's just do that. Again, record, and we expect string and number. Let's initialize empty, and just give it a trace here. Now to collect that, we're gonna do for off. So we're gonna iterate over attributes from metadata. Yep, this makes sense. So if you look at here, the object has the attributes, which is an array. So this is this array, and then we're gonna get each item. In this case, each item has two. It's an object, and it has 2 keys: trait type, which is a string, which is what type is, and then the value is the value. So for each attribute, what we're gonna do is in our traits object here, we're gonna do attribute trait type equals attribute value. This should be all good. And then finally, down here, what we should be able to do is just say NFT traits, I forgot the name, hardworking was the first one. Yes. And then NFT traits efficient was the other one. Yes. Cool. So now you can see we got these, values here. The traits. You would, obviously this is very ugly site. In your real life, you would do something way cooler with probably some icons of, hardness, looks that hardworking, it's very hard, efficient, like, proper icons. But this is not that kind of person doing this. So I'm just doing like E and H, which also works. Yeah, but that's pretty much it, I think. This took long enough, took me 1 hour and 6 minutes to get here, but we're here. So yeah. So I hope this made sense a little bit. If it did not, let me know. Yeah. And please let me know if there's anything else like this that I haven't covered and you would like me to, make a fool of myself trying to do that. But hopefully it gives some sort of value to somebody. Cool. I'm gonna stop it now because I talk too much. Bye. Have a wonderful time.